I know you're out there. I can feel you now. I know that you're afraid. You're afraid of us. You're afraid of change. I don't know the future. I didn't come here to tell you how this is going to end. I came here to tell you how it's going to begin. I'm going to hang up this phone, and then I'm going to show these people what you don't want them to see. I'm going to show them a world without you. A world without rules and controls, without borders or boundaries. A world where anything is possible. Where we go from there is a choice I leave to you.
Hey guys, hey everyone. As always, I like I first need to check the everything is fine. Just give me a minute. So I'm glad to be on this other live. We are doing that to a certain frequency. As always, you should know that this set of live is part of ebook that I'm writing. This ebook is about AI by sci-fi, and the goal of the book is to bring to attention some fiction that they can help you to understand sci-fi. I know that reading can be boring, books can be boring, all the theory can be boring. Unfortunately, reality is much lower than fiction. So fiction is very fast. I mean, the human imagination can be limited. Once Albert Einstein said something like imagination is more important than knowledge. So Einstein recognized how important is imagination. And for a scientist, for a researcher, imagination is everything. I cannot see how science can go on without imagination. You have to imagine the world. Einstein was very active in his imagination. As he said once, it was even harder for him to control his imagination. So physics and the artificial intelligence can be a way to see how imagination can go on. Everything we are seeing today, if you think about it, it's a projection of the human imagination. I mean, one time people used to imagine. Sometimes the moves can get it wrong. For instance, moves what was talking about the flying cars. You don't have flying cars, but on the other hand, move was also talking about big lights. Every movie about scientific fiction, such as Star Trek, they had this huge amount of lights going around. But today, you know, that computer can be so small. Uh, Nowadays, a computer can be so small that can go inside your skin. So, to a certain extent, the pseudoscience behind the vaccine with a chip, very small computer, can be a little bit true. Not 100% true, but at least it's still possible. For example, they have some kind of medicine. Nowadays, they have this kind of tracing, they call biomarkers. And the reason is to find some place in your body that you need to study. So today I'm going to talk about Matrix. I mean, I love this movie. I know that everyone should love Matrix because it was a big hit. They did the fourth edition, the fourth version of Matrix. I didn't have the opportunity to see. I know that I can find this kind of illegal website, but I prefer to respect. I mean, I really want to see, but prefer to wait until it's available on a kind of Netflix or even Amazon Prime. I can wait. Matrix is a movie that I saw when I was in high school. I was a little bit young to a certain extent. But at the time, I saw some articles on Galileo, this kind of scientific magazine that I used to like to follow. But today, I'm not going to talk about this kind of stuff that I saw on this kind of magazines. This kind of magazine, they was always talking about the kind of simulated reality, parallel reality. It's a kind of idea that talks about which matrix is possible based on the kind of fact that we had a parallel reality. So that was the point. But today what I want to talk about was the artificial intelligence behind Matrix. Not Matrix there is a very rich possibility of it's a very rich move in terms of philosophy. But I want to talk about one specific point. As you know, for Matrix, it was specifically Matrix number 1. Neo was able to learn kung fu, to learn every time they want to learn something, they just had to plug, and they will learn in a matter of seconds. So the question is it possible that the human will be able to learn better? Is it possible that a human can learn from a computer? So let me give you a very brief idea how artificial intelligence works. So this live in this book that I'm writing, there are 4 people that are not necessarily a computer scientist, not necessarily a computer programmer, can be anyone that wants to learn more about artificial intelligence. So let me explain briefly how artificial intelligence works. Essentially, artificial intelligence is a set of algorithms. They're called bots. So they are like algorithms. They are like computer codes which execute a sequence of action. It's not different from the previous version of algorithm. The previous version of algorithm, they were kind of stupid. What do you mean? You had to program everything. They would do exactly what you asked them to do. But in about the 1950s, they started to develop a kind of algorithm that could learn. They were called perceptron. So perceptron is a very simple version of this. It's a very simple version of how a neuron works. Initially, they were interested about how can I model the brain. I mean, if you know by now, if you don't know, I'm going to tell you, the brain is a set of cells. The cells, they connect with each other. They have a kind of, they call dendrites. They have a kind of other neuron, but they connect with each other with electrical charge and chemical charge called the neurotransmitter. So they are produced by the neuron. The neurons start to talk to each other. So everything that you have in your brain is a sequence of neurons called the neural network. So the term artificial neural network means that we are create artificial intelligence. So in the beginning, they were very happy because this very simple perception they were able to learn. They are very simple. You can find the internet. They're not complicated. They're just a kind of summation, mathematical summation, plus a kind of threshold. So they are very simple to learn. But by the time people were surprised, they even thought that could be a kind of simulation of the brain. They thought they have just discovered a new way for you to teach machines. So it was a kind of very boom. But soon they realized this algorithms were very limited. Even though they could resemble the brain, they could not do everything the brain could do. A very simple problem that was able to give you trouble to this kind of algorithm is called XOX. It's a very simple problem. You have just a 2D surface, and you need to separate between 2 sides. It's XOX. You can find the internet. So the algorithm could not solve that. So it's a very simple problem. So for a while, artificial intelligence was dead. They could not train because our brain, they work in layers. You have layers of neurons, you have a connection of neurons, so you call them networks. But they could not simulate the networks of the brain. They could just simulate simple neurons, just like one neuron. For about maybe 20 years, neural networks was dead. But they decided to go a little bit more on, because now they decide to go to learn how the brain works, really how the brain works. Explain it in a very simple way. The brain is a set of neurons, a set of cells. they create kind of spike. If you go to the internet, you will find that the neuron, you can measure in the encephalogram the spike of the neuron. They are kind of a set of spikes. So so they create what called spiking neural network. I have a live with Professor Casabov on my other channel. I'm going to leave for you the description of the video. Professor Casabov was the first person that I found that was working with spiking neural network. He's from New Zealand. I tried to do a postdoc, a PhD with him, but I think it didn't work as we wanted. But it was a very nice experience for his course that was in Brazil. But the point that the spike in neural network was a way to try to understand how the brain works. So how the brain is able to encode information, how the brain is able to do everything just by spikes. I mean, they are temporal spikes. So how can you understand the spike of the brain? That's the question of spike in neural network. So the promise that the spike in neural network brings, which is the topic of this live, is that if you see, I'm going to leave from the description of the video, one of the work that Professor Casabov showed to us is that they were able to understand how classical music is composed. I mean, the trick behind the classical music, because if the brain is able to do what is able to do just by spikes, you should be able to decode that. As I proposed to Professor Casabov, I think it's very awesome, this idea that you should have in the brain in the future what they call what I have called super brain. Maybe somebody else took this, already took the name, but the super brain will be a brain that you could communicate with the computer. The computer could do the calculation, and you give the calculation back. Everything is in your brain, because what changed from the past to the present? In the past, as they used to play around, PhD student was just a human calculator. There is some article, you can see that. Even people say that publicly. Today, you will say that your PhD is a human calculator. You can be understood wrongly. People can even try to get you wrong, that you are exploiting the PhD student. If you do not know what's a PhD student, a PhD student is a student that learning to be a scientist. Like he's like a young scientist. I did my PhD, so maybe at least formally I'm a scientist. So a PhD student, just a minute, guys. So a PhD student is a young scientist, someone trying to be a scientist. So in the past, a PhD student would be just a human calculator. So today, most of the calculation was done by hand, by PhD student or postdoc. Today is done by computer. So it means that all the calculation in the past was done by the brain. Isaac Newton, all these guys, they did all this calculation by the brain. So the brain was the kind of was how human used to do calculation. So in the past, to do calculation was just the brain. But in the evolution of computers, now computer is able to do a huge amount of calculation. But imagine if you could ask the computer to do all the heavy calculation. Human will be just imagination. Human will be no longer. Today still have calculation. For example, if you go to if you are an engineering student, you have to do a huge amount of integral. You have to do a huge amount of the hand calculation. So depending of the area that you work, the scientific area that you work, you still have to do calculation. So, but imagine if you could make all this calculation on the computer. But here, I'm going to explain how it works now. Now it works now. Now, what to do? When you have to, I did that on my Master of Science. My Master of Science, I was studying, as one example, I was studying molecular dynamics. So what's molecular dynamics? Molecular dynamics is applied to DNA, is applied to RNA, is applied to material science. I did a Master of Science advanced method to apply to material science. So I was concerned how numerical method can be used to understand, for example, when you have a nanowire and you push the nanowire, how can you simulate that on a computer? How can you ask the computer to do the calculation? So how I used to do? I had to go through days making the codes, and I had to tell the computer how to make each molecule to move, how each molecule is going to move. So I had to teach that to the computer. How I knew that? From mechanics from Newton, from mechanics from quantum mechanics. So I have to tell the computer how it works, but I have to do the code. The big line here, the big possible singularity in the future, which already happened in the past but may happen again in the future, is the line. Because if I have an idea, I need to ask the computer to do the calculation. I still have to have a kind of huge amount of work in the middle in which I have to encode that. I have to pay someone, or I have to do it myself. Some company they pay people to do that, but I have to create a huge amount of code. For you to have an idea, the Newton equation is just one line. Not even one line. The Newton's equation, the second law of Newton, just force is equal mass plus multiplied by acceleration. That was what I have used on molecular dynamics. Everyone used molecular dynamics. But for you to do a code for that is a huge amount of line of codes. So for every single situation in which you have to do this kind of numerical simulation, you have a huge amount of numerical calculation. So that's the big problem. The big problem that even though we have evolved a lot, you still have to tell the machine by you call that computer language, such as Java, JavaScript, Python. They are computer language. They are how you talk to computer. How you talk to computer nowadays. You have to use a computer language. You have to tell the computer how it's supposed to do his work. It's called computer language. So you need the Python, you need the C++, you need the Java. It doesn't matter. You need to have a computer language. The problem is that computer language is very hard to. It's not like it's a big lie that people tell to you that as you become a very good computer programmer, things start to be easier. It's not true. Such as unit testing is a way to make sure that your computer code is not going to crash. But happen all the time. I mean, every time you hear a kind of computer that crashed and so on, that's because the computer programming that you have today, you still need to tell the computer what to do. So that's the big problem. I don't know how I can explain to you, because if you are a computer scientist, you know what I'm talking about. But the point is, suppose it have two steps. You have a heavy calculation, then you have to ask the computer to do the heavy calculation. In the middle, you need to tell the computer how to do that. But you have a huge amount of computer language. You have Python, you have JavaScript, you have Java, you have C++, you have Fortran, which is an old computer language. But the point is, how can I maybe in the future communicate directly with the computer? I no longer need to do that. That's what happened in Matrix. Matrix is a fiction in which people found a way to talk to computer. So they found a way that the computer is able to understand. There is a scene in which Neo, that was in the end of Matrix 1, in which Neo was even able to communicate with the computer outside of the plug. They need to use the plug to communicate with machine. Of course, there is a kind of different story, because they have a parallel world. Human I used as battery. So in exchange of human energy, you can talk about biomechanics and so on, biochemistry, but in exchange of the human energy, they give a human a kind of parallel reality. So if you saw a previous slide about Robocop, the Robocop 2013, 2014, the new Robocop, when the person started to explain why Robocop was so fast, because the first version of Robocop in the movie was slow, because they have the human factor, which I explained the previous slide. So the human factors I explained the previous slide are the emotions. So in order to make the Robocop faster in the response, like he was a cop, so he needed to be fast. So the solution to make Robocop fast on the response was to create a kind of simulation reality. So Robocop was no longer a human with free will. Now they took out the free will by kind of simulation of parallel reality. So that was how human was able to that's how they were able to simulate the parallel reality. So That was more or less what happened in Matrix. Matrix is a simulation of reality. So here I'm not talking about this kind of parallel reality. I'm talking about the communication with machine. Because, for example, when Neo was able to learn, uh, when Neo was able to learn just by a kind of CD, a kind of parallel reality, that was a kind of that was a kind of of that was a kind of that was what I'm talking about. If you could maybe in the future talk to machine, in the future you could not just communicate in the sense of asking the machine to, because today when you have to learn the traditional way, which means hours of lessons, hours of class. So that's the traditional way of learning. So, but imagine if you could imagine if you could learn, imagine if you could communicate with a computer. So that's the challenge. The spike in neural network, which is the one that from Professor Casabov, which is my previous live, is a way to do that. It's still CPAT, it's still a kind of new idea. We still don't know. We still don't know how to do that. I mean, it's still very. So the big singularity that's going to happen is that is the future. We may be able to no longer we may be able to no longer use computer language. So the singularity is when a human is able to talk to machine to ask for heavy calculation, which I have called the super brain, without either a computer language. A computer language can be very heavy and hard to code. So imagine if you understand the future, how can you put information in the human brain without all the learning process, all the boring and sometimes even slow process. That is how Matrix is still a fiction. Matrix is still a fiction because we can communicate with machine. I mean, we can communicate with a computer language. If you know how to go, you know how to encode the Python, which take years of learning. Even have to learn Python, JavaScript, or even any kind of the language, you still have a lot to go. Because as for example, as you know, they learn the as you say in computer, in computer world, the life cycle of the technology in computer science is like 2 years, maybe 5 years at most. For you to have an idea, one language that I like to use is called Angular, TypeScript. Angular, more specifically, is like every 6 months they have a new version. So the velocity as which language changes is very fast. No one can follow that. I mean, we as a computer programmer, we try our best. We try our best to follow. We try our best to understand. So let me explain a little bit more. So yeah, we know by now that Matrix is not possible. Is a kind of fiction because you cannot communicate with computer. You cannot input information in the computer just like a plugin that go in your brain. We cannot teach someone just like in Matrix as you want. But so let me explain how far we are now. Now, the best at this moment as technology, the best you can do is called deep learning. I mean, it's not in the sense of simulate the brain, but the sense of learning. Deep learning is it's just a set of neurons, artificial neural network, which I explained previously what is artificial neuron. It's a huge amount of neuron. So they put this kind of neuron in a huge layer and they train it. How they train? They take human example, then they start to change inside the network, which is just mathematics. There is no magic to that. That is able to learn how to recognize speech, is able to learn how to recognize image, is able to separate a tumor from the brain, is able to separate a dog, a criminal on a video. If you are searching in a huge amount of pile of video, they know how to make this kind of separation. This is how you can go nowadays. But the big issue is that deep learning is unable to understand concept. So today I have two ideas about the artificial neural network. One idea about artificial network is called narrow artificial network, which is about 90 90% or even more of artificial neural network, the successful part of artificial network is called the neural network, which is a very simple, compared to the brain, is a very simple style of artificial network. It's unable to learn in a very generic way. So in this specific case, you cannot go very far away. So the next promise, which is still not matrix, I mean, still very far away from matrix, is called the artificial general intelligence, which is a kind of artificial neural network, artificial intelligence more specifically, that is able to adapt according to the situation. But still, it's still very far away from matrix, because for us to achieve matrix, to achieve the kind of learning that you have in matrix, when you are able to teach someone in a matter of seconds. For example, as you know, when you go to matrix, the first thing that he does is to learn. He tries to learn a lot of stuff, kung fu. He tries to learn. There is a part in which Trinity, she needed to help Neo. I think it was Matrix number 1, and she asked the guy, "Please give me one, give me one knowledge about this specific helicopter or this specific pilot training." And she's the guy that is the operator is able to give her the knowledge in seconds. And then she's able to pilot a helicopter that she never knew before. So this kind of idea that you have in Matrix is still not possible. The only way for you to train a human nowadays is to pass by hours and hours and hours of training, which is very far away from what you have nowadays. The best you can do nowadays is to create the artificial intelligence that is going to be able to do the human work, but not the human that's going to do. For example, when you have this kind of autopilot car, the smart car, the intelligence of the car is not necessarily the human intelligence. That's the reason why some people they don't like the term. When you say artificial intelligence, some people don't like this name. They say that this name is bad. Some people pose the name computational intelligence, because artificial intelligence is not about human intelligence. Sometimes can be human intelligence, but it's not always human intelligence. So if a robot is able to drive a car, is able to drive an automatic car, it's not because it's like human. It's not because one thing that I talk in my book, I have a book called Computational Thinking. One thing that I talk in my book is that one thing that I talk in my book is that human has just a specific one way to learn. The reason why the reason why you go to university, the reason why you go to high school is because there is a way to teach human. So human know how to teach human. You may have very strong critiques about how the school works, how they are not teaching efficiently, but still you can teach human. But machine, they do not have just one way to teach. Machine have several ways to teach. And every single way to teach a machine is called algorithm. So you have machine learning, you have one way to teach the model for machine learning, the model for artificial intelligence. There are a huge amount of model. But if you take just one model of artificial intelligence, you already have another one, a huge amount of model for teaching. So the diversity in the richness of those models in artificial intelligence, they are very high. I mean, there is a huge amount of way for you to teach machine. I mean, a huge amount of learning model of machine learning, and a huge amount of way to teach this model. So every time you create a new way to teach artificial network, that may sometimes even consider a new model. For example, deep learning. Deep learning is just a learning model. It's a model for the brain. I mean, it's not necessarily a model based on neuroscience, but deep learning is a kind of a model for how we should learn. It's very far away from the brain, such as if you see what they call support vector machine, the SVM. they're very far away from the brain, but they are very efficient to teach. So the only similarity nowadays, the only similarity between human learning and machine learning is the name, machine learning, the learning. The only thing that connects artificial intelligence nowadays is the word learning, because all of them, they work in the same principle. They should show some examples. It should internalize that example. How that's internalized is different. How that's done is different. So that's the reason why matrix is not possible. Why this matrix is maybe it will take a huge amount of time until we are able to get even close from matrix. So the reason that even though fiction was able to, even though fiction was able to go very far away, was able to give a huge leap, was able to give a huge jump of imagination. On reality, that's not what happened. In reality, what you have is a set of models that they are unable to simulate the brain. I mean, so because there is a huge fight inside the artificial intelligence. Some people think that it should go toward the brain. Others think that should not worry about the brain. There is a very nice GIF which I'm going to try to share in the future with you guys, in which they show a plane taking off, then the plane starts to fly. That is more or less what's behind the artificial intelligence nowadays. Some people say that you should fly. Some people say that you're supposed not to fly, I mean, like a bird. Some people say that the plane should just fly. Some people say that some people like it was a kind of paradigm shift in artificial intelligence, more specifically, in artificial neural network. One of the paradigm shift was that you don't have to imitate the brain. That was so deep learning is not imitate the brain. Support vector machine is not imitate the brain. So from the moment that the intellectual, the community, they said to themselves, I don't have to imitate the brain. That's the work of neuroscientists. Neuroscientists have to create models because you can create two types of models. We can create one model that the main goal is to learn, or we can create one model that the main goal is to simulate the brain. One of them that simulate the brain can be called biomathematics or mathematical neuroscience, which is different area from artificial intelligence. Artificial intelligence is mainly computer science. It's mainly a kind of engineering stuff. It's mainly a kind of stuff that artificial intelligence is concerned about solving problem. As long as the model is able to solve a problem, they are going to be accepted. You can create a model that is very stupid. There is nothing to do with the brain. But if the model is able to, in the case of deep learning has nothing to do with the brain. I mean, the only thing that deep learning has to do with the brain, that you can say that if you want to make a talk about deep learning and you want to present this talk to a group of neuroscientists, the only way that you are able the only way that you are able to sell your point, suppose that you want to convince you want to give a big talk to neuroscientists or to medical doctors, so on. But you want to make sure that you are not look like a fool. So you want to make sure that you want to convince the computers, convince the neuroscientists, you want to convince the biomathematician, the medical doctors that your model can simulate the brain, or that you want to sell something. You want to go there, give a talk, get like, wow, you are awesome. There's two ways that you can convince a neuroscientist, which is, by the way, if the guy is very smart, he's not going to buy it. We're going to buy it for a very short, specific period of time. Soon they're going to realize that's not totally true. The first way to sell your deep learning is to say that it learns. My model learns. That's true. It learns very well. For you to have an idea how deep learning was successful, the Google Translator is no longer the previous artificial network. Now Google Translator is based on deep learning. So to show how it was successful. For you to have an idea how deep learning was successful, the mistake rate of image segmentation when you have an image, you need to separate something from the image, like dog, cat, people, car. You need to separate like human does. It's like 5%, which is a very low mistake rate. Very low. Deep learning was able to revolutionize the learning machine world. That's why today it's all about deep learn, deep learn, deep learn, deep learn. To have an idea, China is investing a huge amount of money in deep learn because from an engineer point of view, deep learning is very powerful. The second way for you to convince a neuroscientist that your model is like awesome, like they should buy your model, they should invest in deep learning, is that you say to them that deep learning is based on layers. Because the human brain is based on layers. You have the outside layers, which is based on learning. The outside layer that's called cortex, they are based on neurons that are very, very flexible. Then you have the inside the inside layers, like the inner layers, like, such as the hypothalamus, the cerebellum. You have all this kind of inside layers. So the brain was evolved in layers. So that's one of the reasons why you can say that my model is able to learn and my model is full of layers. But if outside of that, you cannot do anything anymore. For example, there is no spiking in deep learning. There is no, I would say, no connection between parts like you have in the brain, So deep learning is not neuroscience. It's awesome as a learning machine. It's awesome as a kind of model for you to use. And they are using some model deep learning. For example, I saw one model based on deep learning that he's able to replicate the drummer of a band, and he was able to replicate very well because I'm very bad at play piano. So I tried to play the piano very badly, and he was able to replicate. And you can see a huge amount of example how well deep learning is doing. But the sad part that it's not even close from the brain. I mean, it's very far away from the brain. So that's one of the biggest critics against deep learning. And that critique is not new because deep learning is a continuation of the previous type of neural network. Deep learning is called the multi-layer perceptron. So it just increase the amount of layers of the multi-layer perceptron. So deep learning is not something that's new. I mean, it's new. What's new in deep learning? It's new that you were able to pack a huge amount of layers. It's new that you were able to train this huge amount of layers packed together. It's new the kind of approach they are using. But the principle behind is a continuation of the previous multi-layer perceptron. So the failure that they have in the 1950s with the single perceptron, then they failed with multi-layer perceptron, is what deep learning was able to do, which is not totally new. I mean, in the sense of neuroscience, in the sense of the brain. What is new in the successful rate is how successful deep learning is. That's what the novelty. But not new in the sense that it's like revolutionary, in the sense that it really understands the way the brain works. So if you want to make matrix possible, we will have to understand the brain. Matrix is just possible if you think in terms of neuroscience, because what happened in matrix is that you have information like how to fight kung fu, then you have input in the brain. Because kung fu is a very nice example, like soccer play, like a football, because you different from how to solve integral, different from how to learn. That's a very complex stuff because the brain communicates with the muscle. It's teaching. They call it like a muscle memory, like a kung fu fighter. He has to pass like a soccer player as well. They need to stay years and years learn how to. I haven't ever done kung fu, but when I was young, I used to read some book like I want to learn karate and so on. Have seen some kind of moves and so on. You can see that what they do is to repeat to your brain this kind of movement. So they teach you a kind of repetition. So there is a very strong connection between the brain and the muscles. So all the very fast that they do is a kind of learning process that matrix you have to. So especially this part of the kung fu, it's a very far away part because for us it's one of the biggest challenge of the artificial network nowadays is the part of the moral part, the moral part, the part that he is called Maverick principle. I never remember his name. Essentially, it's a paradox. It says that what a very young child can do, a very young child can do in terms of moving, the machine, they have a huge difficulty of doing that. So in order to make matrix possible as a way of teaching someone how to fight kung fu, you would have not just to master the artificial intelligence, you have as well to master how to communicate with the muscles, which is something that you don't know. I mean, we have some kind of theories that they say that if you keep thinking about suppose that you want to practice something that has a kind of moral part, like muscle part. Some situation you keep thinking about that. They see some studies show that you are able to even to partially train it. You do not need to necessarily do all the movement. So that may be a kind of training between your muscles, the part of your body, and the part of your body. So this is a kind of movement that you should like master. So there's a huge amount of step between reality and matrix. So the first thing, the first difficulty is how to master this connection between knowledge and the brain. How to enter this information in the brain. Even if you do not have the moral party, you still have the challenge. You still don't know how to understand it. If I give you an encephalogram and they ask you to understand what's there, the best that can do nowadays that they can see part of the brain that are responsible for certain kind of movement, such as some people are able to pick part of the brain that they can make the finger move. So they know more or less which part is responsible. But the problem that you cannot transform the spike if you take an encephalogram. You cannot make the movement between, say, this spike is responsible for this. In the work of Casabov, with some Weber, my other channel, he was able to, they were able to understand how the classical music work in the system of spike. But this understanding is not complete yet. I mean, for example, if you want to understand how Beethoven works, like the brain of Beethoven, the brain of Mozart, the brain of a very, very, very important scientist, the best you can do is to transform this in kind of spike. But you cannot understand how to decode that. How can you transform? How can you create a computer, a brain language? A brain language is a way to communicate with machine. So for you to have in the middle the communication, you need to have a brain language. You don't have that. The best you have is computer language. So the work of a computer scientist or computer programmer is precisely to transform that into a language in which they have to get the knowledge, they have to get the challenge, they need to transform that in computer language. This is a very painful, painstaking work. It's a very, sometimes expensive because there's a huge amount of mistakes, but you still can't teach the body, still can't teach human. You cannot give this information for free. So guys, I hope you enjoyed the live. I'm very happy to be here as always. As always, keep your eyes sharp to the upcoming live. This live is part of a book that I'm writing. So I'd like to invite you all to keep following the lives, because every live I'm talking about one chapter of the ebook that I'm writing. So when I give you a feedback, that helps me to find what to write in the book, what's the best part in the book that I should give attention to. Because the book, the ebook, supposed to be a kind of fun, like have fun watching Netflix. So how can you watch Netflix and still have fun? How can you learn about artificial intelligence and still have fun? Artificial intelligence is a very interesting topic because everyone is affected by artificial intelligence. You may deny artificial intelligence. You may say that's not my business. It is your business, because they say that in the future, artificial intelligence will be the next way in which nation is going to fight. That's why China is invest heavily on artificial intelligence. That's why most of the big nations, they have a project. They are fighting for training their only people to understand artificial intelligence. So the future belongs to artificial intelligence. So that's the reason why I should your guys you guys all should learn what is artificial intelligence, your IP with our sharp to artificial intelligence. So see you in the next live. So please feel free to comment, feel free to share, feel free to make the clip, and I hope you enjoy the show.
I know you're out there. I can feel you now. I know that you're afraid. You're afraid of us. You're afraid of change. I don't know the future. I didn't come here to tell you how this is going to end. I came here to tell you how it's going to begin. I'm going to hang up this phone, and then I'm going to show these people what you don't want them to see. I'm going to show them a world without you. A world without rules and controls, without borders or boundaries. A world where anything is possible. Where we go from there is a choice I leave to you.